All right, we're going to go ahead. We're going to take a look at how to do some ANOVA analyses here. So I'm going to focus on, in this video, specifically on the one-way ANOVA, and then I'm going to mix it up a bit, adding in a second independent variable to create a two-way ANOVA. So this data here is the data I like to play with for an example. It is example data. I stacked it on purpose to give nice, clean examples. For the one-way ANOVA, I'm going to start by looking at these behavioral scores here, specifically the year end. So these are 8th grade students who they're in one of two districts, and they are either getting or not getting this positive behavioral intervention system in their school, which just helps students to build these positive behaviors. So I'm going to look at the year-end behavior score for these kiddos, and I'm going to look at it based on first their ethnicity to see if the year-end behavioral scores are different based on the different ethnicity groups. And then I'm going to add into the mix what district they're in to see if the way that the scores play out for the 3 different ethnicity groups is the same in District A as it is in District B, or if it's different in those districts. To run an ANOVA, very straightforward. We're going to our ANOVA tab, and I'm just going straight to ANOVA. I'm not doing any of these fancy guys here today, just going straight to ANOVA. In here, I'm going to put in my dependent variable, which in this case is the behavioral score at the end of the year. Your dependent variable is never one of your categories. It's always that kind of continuous variable that you can get the mean or the average score for. And I'm going to start with a fixed factor, which is the same thing as an independent variable. I'm going to start with ethnicity, and I'll see my results start to pop up over here. I'm going to add a couple things to that. I want descriptive statistics and also the estimate of effect size. And I'll be using this guy here, which is pronounced eta, ETA, eta squared. So what did we get? What did we learn? Well, we've got two things. First of all, the general results of our ANOVA. The ANOVA value that we get, just like when you do a t-test and you get a T, when you do an ANOVA, you get an F. Okay, and this is the number that came out. It's quite small. It's corresponding with a p-value that is also showing us that there's nothing significant going on here because it's very big. Remember, p-values that are tiny, less than 0.05, we say are significant. This is a very large p-value. It's a 0.97. Okay, the eta squared is also super, super small. This -4 is showing us that we would have to move the decimal place out 4 places and give us a very, very tiny little decimal. It's so small, it doesn't even fit on the page here. All the leading zeros don't fit on the page. So we know that it's very tiny. What does that actually mean in terms of context? Well, let's look at the descriptives. Our behavioral scores at the end of the year for African American, Caucasian, and Hispanic are all very similar. 1.19, 1.17, and 1.18. There's nothing going on here. These guys are all very similar to each other. So how would we write this up? Okay, let's have a look. First thing you want to say is, what did you do and why did you do it? Okay, a one-way ANOVA was conducted. Why is it a one-way? Because there's one independent variable, ethnicity, right? One independent variable. Let me just flash back quickly. Here's our dependent score, and here our independent variable box, 1. So it's a one-way ANOVA. One-way ANOVA was conducted. Why? To compare the average end-of-year behavioral score between the 3 ethnicity groups. Right? Okay, what did we find? The ANOVA was not significant. We got to give them proof of that. I'm going to type it in first, and then I'm going to walk you through where I'm getting these numbers from. Our F statistic is teeny tiny. Our p-value equals 976, very large. And eta squared is also very small. Okay. The average for end of year behavioral scores were similar, with an average of 1.19, standard deviation 50 for African American students. Again, I'm going to walk you through all of this. Let me get it down on the page, so to speak, here. I don't need that. Caucasian students, and what do we have here? 18. Really is very similar, isn't it? It's almost like somebody made it up that way to give you a nice, pretty example. All right, here we go. What did I do? Why did I do it? I did a one-way ANOVA so that I could compare the average end of year behavioral scores between the three ethnicity groups. What did I find? It's not significant. How do I know it's not significant? Because the p-value is very big, right? P-values less than 0.05 are significant. This one is not significant. So I got to give them the proof of that. Excuse me, I have a typo here. I'm going to tell them what the F statistic is, right? Here's the F, and that it's equal to 0.024. That's what the table's telling me here. But I've got to interrupt that, thank you APA for this rule, to put these little degrees of freedom in here. So your degrees of freedom section right here in the table has two numbers. You put them in separated by a comma. You don't put it in as 2,279. You put it in as 2, comma, space, next number, 279. Okay, just a formality piece that you need to do here so that if we were going to double check these numbers, we would have the information we need to go in and double check it. Then you put the actual F statistic. Then you report your p-value. You should put the exact number in here. Please do not tell me that it's greater than 0.05. Tell me what the exact number was. The last thing I'm putting in here is the effect size. So let's talk about this and what the heck I did here. First of all, I did not put in the Greek eta symbol. If you see this, this is not a normal N. It's an actual symbol. In Microsoft Word, you can go insert symbol and you can find it. I'm just holding the space here for myself right now with an N and a 2, and I will format that later in Microsoft Word. I'm not typing in 1.731 e to the -4. I am saying this is a very small number. And the way we do that in APA format is to say less than 0.001, because it is definitely, in fact, less than that. Okay. Anytime you get this kind of scientific notation, the number is less than 0.001. So I gave them the googly glop to show them, yep, it's definitely not significant and there's a very small effect size. And then I have to tell them what that means in context. Well, what it means is that the end of the year behavioral score is really similar for the three groups. How similar? Well, this group had 1.19 as their average, and then I put the standard deviation right next to it in parentheses. The next group, 1.17, that was their average, M equals. I put the standard deviation right next to it in parentheses. And the third thing, same format, M equals, and then the standard deviation right next to it in parentheses. All right, so that we can see, sorry, I won't catch all these typos, but I'll try, so that we can see that they're all very similar to each other. Hey, here's a fun fact. See the standard deviation that I put the leading 0 before the decimal? I did that on purpose because I follow APA, and APA says if the number could theoretically go bigger than 1, which of course the standard deviation could do, then you have to have a leading 0. Fun fact. All right, shall we take it up a notch? Of course we should take it up a notch. Let's shift it up to what we would call a two-way ANOVA. Okay, and in the two-way ANOVA, we're going to add a second independent variable. Great. Here we go. We're going to say district. Okay, there's no difference in ethnicity, right? 3 ethnic groups have similar behavioral group scores. But what if I split them between District A and District B, and then I looked at the 3 ethnicity groups? Are they still all the same, or is one district looking different than the other? Just pop district in the box here, and your information will automatically update. Love it, love it, love it. So what do we learn here? Well, first of all, we have this one-way ANOVA for ethnicity. We have it for district as well. And look at this. The districts are not the same. It's telling me that overall, the averages for District A and B at end of the year are not the same. Okay, if you break that down in each district so that you look at it for ethnicity, what do we see? Right? Well, actually, no significant difference there. So even though District A is different from District B overall, when you break it down into those three ethnicities, you don't have differences between the ethnicities. Let's look at this a little bit more deeply. In District A, African American average is 1.26, Caucasian average for District A, 1.24, and Hispanic average for District A, 1.39. But for District B, 0.86 for African American, 0.94 for Caucasian, and 0.97 for Hispanic. So what are we seeing here? First of all, District A has higher behavioral scores than District B, and that's what this is telling us, right? And that's significantly so, which we can see. District A, they're all over 1.2. District B, they never break 1.0. They're ranging from 0.86 to 0.97, right? But if you look at the actual ethnicities, they're still all pretty similar, right? For District A, 1.26, 1.24, and 1.39, which feels like it could be a potential anomaly, but according to this, it's saying that it's pretty steady. District B, same thing, 86, 94, 97. Okay. See what's happening there? See what's happening there? All right. So you could write that up and explain that. Let's do an example of that. There's going to be multiple pieces if you do a two-way ANOVA. A two-way ANOVA was conducted, right? That's the first thing you need to do, is tell us what kind of test, right? The ANOVA, what did we do? Compared end-of-year behavioral scores between ethnicity groups. Oh, goodness gracious, hang on. Between ethnicity groups, district, and the combination of district and ethnicity. And then you move on to what you found, right? The ANOVA was significant for ethnicity. And then you're going to put your numbers in there. The ANOVA was, I'm sorry, it was not significant. Was significant for district. And then you're going to put your numbers in there. And the interaction between ethnicity and district was not significant. Let's do a little bit more detail here. The ANOVA was not significant for ethnicity. I'm going to tweak this language a little bit, right? This is how we started in our last ANOVA, but because we have more than one independent variable, we can actually change our language. And what you will see is kind of the norm out there is that people will say the main effect of ethnicity was not significant. That's the same thing as saying the ANOVA was not significant for ethnicity, but this is how people say it. All right, so you have to kind of adjust a little bit, that the main effect of ethnicity was not significant. And now we would switch this one. The main effect of district was significant. All right, and then the third piece here is the interaction. That's exactly how we say it. The interaction between ethnicity and district was not significant. And you have results for each of these here. Okay, so for ethnicity, we're doing F, and then we have to put our degrees of freedom in there. And then we're giving them the number. And we're telling them that our P is 0.237, and that our eta squared is very, very tiny, right? For the next one, so these numbers here, oh, I keep doing that. These numbers here come from this line here. The next line for district is what we're going to put here. This one's a big one, 34.425. P-value is less than 0.01, and our eta squared is 0.11. And then for the interaction, that's this third line here. So now we just have a lot more information to type out, but it's all the same, right? It's not not necessarily difficult. It just takes a minute to look and make sure you're looking at the right thing and follow through with typing out the information. All right. And then we could write and describe what's going on here with the averages underneath. I want to show you one more thing. And this doesn't necessarily apply here because we don't have significant differences here, but it does apply to the last ANOVA that we did where we had a significant difference in ethnicity. So let me take this guy out and go back to where we were originally, right? Where we had ethnicity scores. They're not significantly different. I got that. But what if they were, right? How would we know who's different from who? You know, if we run the test with district, there's 2 districts. So if the test is significant, it's like, well, district A is different from district B. But when we have more than 2 groups and it is in fact significant, who's different from who? Are they all different from each other? Or is there just one group that's very different from another group, right? We actually saw this in District A. Let me pull up those numbers. Here's a cute little trick. If you go to district, right, you can X out a group. You can do this with any of your categories. So that down here in your data, you're telling it, let me scroll. I want to look at all the District A data, but just ignore the District B data for a second. So you X it out, it grays it out. Okay, this is a little bit of a side trick, but it's a nice little trick. Watch what happens. Now suddenly our numbers change over here because now I'm looking just at the District A data. See how we no longer have the same sample size of over 200 students. We have only 191 now because it's just the District A data because I just grayed out District B just for a second. I did that because you start to see differences in the numbers, right? And if this turned out to be significant, it's not. Our p-value is still 0.27, right? But at least descriptively, we can see here. Wouldn't you want to know, is it the Hispanic students that are different? Because these 2 groups still look pretty similar, right? Wouldn't you want to know and do that comparison where you're actually saying, yeah, Hispanic is significantly higher than Caucasian. Hispanic is significantly higher than African-American, but African-American and Caucasian are still similar. You would want to be able to do that kind of dissection and that pair by pair analysis. You can do that. It's called the post hoc test. So this might come up for you and you may need to do this. And you just go to the post hocs, you just pop it over and it'll just pull a table right up for you that does all the comparison tests. Again, our p-values are not significant in this example, right? I'm just kind of walking you through this so you can see how you would do it if you needed to do it. But it does all the comparisons for you to help you see. And you can see the Hispanic students compared to Caucasian have a 0.14 point difference. Hispanic students compared to African-American students has a 0.13, and the African-American and Caucasian are much more similar. Yeah, exactly. That's what we saw up here when we were looking at these numbers. So you can do this breakdown comparison. It gives you a t-test instead of an ANOVA. That's fine. With a p-statistic that's called Tukey corrected because there's more than one. Don't worry about it. Just you know how to interpret this. They're bigger than 0.05. So these differences are not different from each other. But if you had an overall significance here, you would want to know who's different from who, right? Who's different from who. So that's another piece of the ANOVA that I just want you to be aware of and that you can use if you need to. All right, so we did a couple things here. We looked at one-way ANOVA. We looked at what happens if you put a second independent variable in and now you have a 2-way ANOVA. And we also looked at some post hoc tests. We've got a good idea of how to pull the numbers out of here and report them, how to look at our average scores. And I even showed you this little side trick, which was nice. If you want to filter your data and only focus on a specific group for a period of time, you can do that. The nice thing about JASP is every time you do that kind of stuff, it automatically updates all your analyses so you don't have to keep pressing all the buttons and rerunning things. All right, everyone, that's it for ANOVAs. I think that's plenty of time for ANOVA today. Go get them and have fun.